I'll start today with a topic I called it intersection of technology and crafts. So how can I use the high tech and how can I still have the taste of manual and hand skills and I put it together. So first of all, I need to do something. I will break the rule, and I have a nice video talk about how you can program your mind and see beyond, because all what I have now, all what I will show, I'm here because this kind of videos, because I start motivate myself and I start see before I hold. If you can see it here, you can hold it here. So it's kind of train yourself to have a sort of vision. You can see and imagine, and then you can. So I have this video, I wanna share it with you. So
let's imagine for a few moments what our life would be like if we could access, let's say, 20% of our brain's capacity.
If you want to have something show up in your life, the kind of person you would like to become, manifest something new into your life, something powerful, whatever it might be, you obviously must first be able to imagine it. Your imagination is able to do all that you ask in proportion to the degree of your attention. So, what kind of attention do you place on your desires? Einstein's most famous quote, one of his most famous observations, he said, imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. Logic will get you from A to B, but imagination will take you everywhere. Make your future dream a present fact by assuming the feeling of the wish fulfilled. That which you feel yourself to be, you are. And you are given that which you are. So assume the feeling that would be yours were you already in possession of your wish. And your wish must be realized. So live in the feeling of being the one you want to be, and that you shall be. If this assumption about what you would like to become is persisted in until it becomes your dominant feeling, the attainment of your ideal is absolutely inevitable. You must first assume the feeling of a wish fulfilled in all aspects of your life. Don't allow anybody else's opinions. Don't allow what it says on the internet. Don't allow the research. Don't allow what anybody out there tells you is possible or not possible for you. But if you advance confidently in the direction of your own dreams and endeavor to live the life which you have imagined, you will meet with a success unexpected in common hours. It will chase after you if you can place into your imagination what it is that you would like to attract and begin to feel it. Start retraining your subconscious mind. And your subconscious mind, it responds to what it is that you suggest to it. Your subconscious mind rules your life. 96 to 97% of everything that you do is done as a result of your subconscious mind. And when your subconscious mind is programmed, it goes ahead and responds to whatever it is your conscious mind has placed into it. You are the creator. This is the mystery. This is the great secret known by the seers and prophets and mystics throughout the ages. This is the truth that you can never know intellectually.
just imagine, and I was thinking, how can I do engraving on stone, natural stone? And for 1.5 years, all what I do, I just have my block knot, and I just close my eye, and I have my pencil in my hand, and I just imagine I'm engraving. I have a machine. I will do it. I will do it. Within 2 years, I have my machine when I was in Egypt. And it's the same machine it was in my, when I think about it. And then I start to study and read about the technology and read how it works. So what I'm talking about now, I'm talking about how you can have a natural stone and something it's very ancient, like it's the sandblasting techniques. Sandblasting techniques, it's used to do it for cleaning, for glass, like you just sandblast the glass, and how you can control it and make artwork from it. So first we have to talk about the sandblasting as what you call in the beginning, like when it starts just only for industrial applications. And I need to first to give you a hint what is the sandblasting is. Sandblasting, if we look here, it's equipment work with this cabinet or this pot, and we have a sand inside, and we connect it with air. And with this air goes in, it's make sort of pressure on the here place, and once I release it, it comes out air and sand. So I have to have an air compressor, very powerful air compressor first, and then I connect it. I put sand here. It's not a natural sand. I have, we use aluminum oxide, or we have what you call silicon carbide. It's very sharp and very powerful. So when it goes here and it go out, it comes very powerful and can eat anything. So this is how it works. Air come from here and go inside, and sand inside, and it goes and it come out like this. So usually they use it for industrial, like this. It removes the rust from the metal. It eats. And it's very ancient techniques. It's not like, it's around 80, not maybe 80 years or something. Before they used to use sandblasting, is not like etching, it's use the chemicals. But now it's something like, as you see, it's sand and air and can kill. It's very powerful. Yeah, it eats layer of metal. If you have a rust, if you have the first layer, it eat. If you focus in one place, it start eat until it goes through.
And stick.
No, there is no stick. It's just it goes.
It's like scratching.
It just is scratching exactly.
Yeah.
So when I want to explain, like, okay, so if you have a surface here, this surface, when sand comes, it start itch and take little bit. If you more, it will go more. More, it will go more. You understand? And when you still move your hand like this, it start itching evenly. It will be in one level. Okay? So if I just focus in one place, it will start doing this shape, because it will be very wide here, and then it comes very narrow until give you the V shape. Okay? So when I know I met with this technology, it's like I never see it before. Like I was in a dental lab for dentists, it's like crown and bridge and all this stuff. And I told the guy, can I use it? I need to do some stuff. Like, he said, okay. So the idea it was when I have the cabinet, and I will show you what I'm talking about. What is the cabinet? And they use it for cleaning the metal after modeling for to do crown or it's like jewelry process. You have a wax, you put it, you mold, and then you need to clean the metal. So I start doing some stuff like exactly if I put my hand here and I have a spray or I have any kind of, it become like a stencil. If I just spray here, everything it will be here, except my hand, right? So this is exactly what I did. I did mask. I just bring a tape and I put it, and when I put it, I start cutting, and when I cut it, I start sandblast. So I'll show you a video about what is the sandblast, what I'm doing now. This is a mask we'll talk about.
0.5 mil and 5 mil.
This is a 5 mil.
Our series comes in 3 thicknesses: 3 mil, 4 mil, and 5 mil. The first step for any photoresist is creating your artwork. Most vector programs will work for creating the artwork.
So we'll stop here when we talk about creating your artwork. So we talk about, first you need a stencil to do your artwork, okay? So where is your artwork? Where it comes from? It comes from image, and this image you have to put it in a computer, and you have to have a lot of process. And yesterday, Mr. Eric, he gave us about how to use a vector and what's the difference between a vector and image and with the pixels. So the vector, it's very good example to use it for this technology. Because all what you need a very clear image like this. It's very dark. We work with just only monocolor. It's just only black and white. So when I start doing this, I need first stencil. So how I apply my artwork on this stencil to have it in my project. So first we have to have our artwork. So I start doing something like this. From image, this is a real image. And then we draw it vector. So I can control it and I can have it in any size I want. So here we start using technology. It's digital designing, and we start doing these images. All these images start like this. Here, image, we draw it, and we can control it. Okay? And then after we draw it, and it becomes a vector, and we turn it to black and white like this. We need to print it first, and I will continue here.
But some common programs used in the sand carving industry are CorelDRAW, Adobe Photoshop, and Adobe Illustrator. With washout mask material, you will be using positives for your artwork. The artwork is one of the most important parts of the process. The higher the quality or density, the easier the rest of the process.
Here he talk about this film, it's washing film. Okay. Inkjet film, I'll show you, and I need to pass by. Okay, when I bought my machine, and first time I used these techniques, I used my inkjet printer, and it was like, okay, I just printed, and I need to do it. Nothing, it's bad. It's very bad. What's going on? I called the company and said, no, you have to have this certain type of printer to have very dark and black. It's very solid. Can't allow the light goes in. And we will know why we need to be very dark and block the light. So if we look here, this is my tries. We can pass it. Like, you can have it and just pass it. And we can, it is the same. We can have from here. When I start to print here, and if you look to light, I can see I'm talking about black. So when I fix my problem here, it becomes very dark. So you can have the light one, this is bad, the good one, and we will know why we need the very dark like this. So until everybody see, we talk about, we will proceed.
Inkjet can be used in inkjet printers. Vellum or positive FX can be used in laser printers.
And they did already for laser and for inkjet, but the best result it comes from inkjet because it's really give you it can plug the light.
That media will give you the highest quality artwork.
Stop here. You see this lamp? This is, we call it ultraviolet. It's UV light. So after we make the film, we put the design on it. We have this material. It's rubber. And this is like, it's a 3-layer. We have a carry sheet, and we have here the sensitive to light. This is, I can't expose to light, but this is, it's a bad one. So what I'm doing, all what I need to have my stencil, and I'm sure it's very dark, and I have start put my designs here from the inkjet, and all what I need, and I put it together, and I put it around this light. How? We will see now.
The shiny side of the mask will be placed against the black mat, so the dull side will be facing up. The printed side of the artwork will be placed against the dull side of the mask. This is called emulsion to emulsion. The electrolyte is the most common exposure unit used by customers. But larger professional exposure units.
And this is a big one. You can use it.
Production runs. Exposure times will vary depending on the mask thickness and the age of the bulb. 3 mil to 4 mil mask can be exposed at approximately 25 to 40 seconds. 5 mil mask can be exposed at approximately 45 to 60 seconds.
It's just only less than a minute you can have a ready-made mask. But how we can do it, we'll see now.
After the mask has been exposed, it is time to develop with water. When developing the mask material, you can manually develop with a flat spray trigger jet. You can use a pressure.
So after we finish from making a mask, we need to see the design. So what's happened here? Light, when it goes through the clear one, and the black one, it blocks the light. So here we have two different surfaces now. Surface, it's because the light, it become hard, and the black block the light, it becomes soft. All what I need, just start washing with a pressure water, so it goes for the soft one and eat it. So, and they have, this is a manual technique, or this machine, it's for mass production if you need to make a lot of numbers. So this is washing, once you close it and start spray water and washing.
Depending on the method used. When the mask is completely washed out, the image area will be clear with no color in the area that will be sand carved. The white background helps to see if your stencil is completely
So the result will be like this.
Several methods.
And because it's wet, we have to dry it. So we have regular dry, you just hang it like this and leave it for 20 minutes. Or you can have a dryer if you have production and you start put it for 10 minutes or something to dry. Once it's dry, it becomes sticky here. And when it becomes sticky here, we need this paper just only to put the mask on it, to use it, just and start cutting. So this paper is a little bit, so you can have it to lock, and you see this piece of mask, so you can pass it. Before this, it was full hand cutting.
Yes, it was like the negative and that, and then screen printing, and again remove.
No, this is the same technology of screen, silk screen, but for a rubber, it can resist. Oh, thank you. Okay? So we have here extra, so you can see.
For drying the mask material. Hang drying, shelf dryers with
And the washing with the hot water,
conveyor dryers for high
so
production.
it's easily to
It's
eat.
important to keep dust off the mask material during the drying process. Dust particles can cause mask failure during the sand carving process. When the mask material is dry, you can apply the mask directly to your substrate, or you can apply the stencils to silicon-treated release paper. Release paper is used for the masks for future use
This is the reason.
and to protect the adhesive.
The paper, you have it now, and you see how.
It is important to clean your substrate prior to applying the stencil. This
So now we
will help
apply.
remove any oils or residue and give more success during the sand carving process. Apply the mask sticky side down against your substrate. Self-adhesive mask material is pressure sensitive, so a squeegee can be used to apply pressure to the mask for adhesion to the substrate. When the mask is applied, the carrier is removed. A piece of tape can be used to help remove the carrier from the stencil. Once the carrier is removed, it is important to eliminate any trapped air bubbles in the mask. A wire wheel is a handy tool that will help relieve unwanted air in the mask. Masking tape is used to cover or protect any open areas from getting sandblasted.
So as you see here, once we apply the mask and we put it whatever, stone, glass, anything, just name it, we start going for the dusty process. It's supposed to be dusty, but they make a nice machine now. It's very clean. You can use it in your room without any dust.
Sand carving your parts.
This is a machine.
Parts.
It's a small cabinet. All what you need to put your hand here. You have a side door. You open it. You put your artwork, and you close it. As I said before, it's this tank. It's connected with air, and the sand inside here. And then once you have everything, we have a ventilation or what you call dust collector. So everything, it's clean environment. You can see everything.
Turn your sandblaster on. Adjust your sandblast pressure. Load your part into the sand carving machine. While sand carving, always hold your nozzle at 90 degrees. This will help eliminate mask liftup, which is caused by air getting under the mask during the sandblasting process.
Less than a minute, you have artwork ready.
Thicker mask material will allow for deeper sand carving. When you have completed sandblasting your substrate, you can use your air blow-off gun to remove grit particles from the substrate. To remove the mask material, you can dry peel the mask.
This is for mass production.
You can use water to speed up the removal process. Some large production facilities use industrial dishwashers to speed up the mask removal and clean the substrates in the process.
And you can, okay.
Several methods can be used. One method is spraying the substrate while leaving
Before you remove the mask.
When the entire etched area is paint filled, you can dry peel the mask. Ultra Peel was designed for paint fill applications and is the mask material we recommend for any paint fill application.
So this process, as you see, it's a lot, right? And you don't have to be an artist and you have a very sensitive hand to cut or anything. I start this business when I'm using my hand, cutting. If I have a design like this, I cut everything I want to engrave. And then I engrave and I spray or I paint, it depends on, and I clean. So now my turn to see my video. First, my video here, when I'm doing different technique. Here, when I talk about intersection of technology and crafts, when can I use a very high tech, and I use it's just only for one process, and then one of the process, and then everything is manual. So you have the test between the high tech, and you still have the test of handmade and the. Here, when I was cutting, it looks like it's already made. The stencil is cut. So when I look to this, okay, this technology and this technique, I did it already. But after I finish, I have my artwork, and I have my ceramic tile, and I want to put it in the middle. It's very hard to locate it. It's very hard to position, and you put it in the middle. So it's like I start thinking what I can use to make it very accurate, and it's in the middle, or I need to make a pattern. I need to be connected. So I start thinking, and then the time. I know I'm jumping, but it will everything it will connect it now. So I start using a laser machine. So I bring a mask, like a paper mask, like what you have here, the mask tape here. And I start cover my artwork. And in a laser machine, I can locate where I can cut. I just only cut the outline of the artwork. And I decide, I need to engrave here, I will peel this piece. I need to protect here, keep it, I will keep it, okay? So I did the same result of this complicated. So there you have this. And I have a visit from the company, and they came to my studio, and they saw what I'm doing, and they told me, one of them, he told me, I'm working for 12 years, and this is the first time we see what you are doing here. It's out of our world. Only what we know is just only these techniques. And even when they use a laser, they create a new mask for a laser. And it's also the same technology. The same, but instead of doing all this process of washing and light and all this stuff, just I put it in my project, and I put it in a laser machine, and I have to do it in a certain way. It takes a long time. So the result of all this, you saw here all this design, like this one. So this one, it become this one. So I tried with this. But my issue, it was how I can locate it and it become even. What if I want to make it for the whole, and I need to make it connected to use it for tiling and to covering. It's very difficult when you use it manually. So this part I need to skip, this part I use the technology, and then I come up to my manual techniques.
This is a ceramic?
This is a porcelain. Okay. So that's why I made this to show you how it works. So we have the tile, and apply the mask. I use their technology. They gave me this, and I said, okay, I will try it. And I use a laser here, and then I use engraving, and I have the result. And when I use a laser directly to the tile, I have this etching. It's just only, so the laser can't do what I'm doing when I merge between the sandblasting and laser. So you can see the difference here. So you have something else from here? So So I just keep the sound because it's really loud. So what we see here, this piece, it's here now. So the same artwork is here. So I make 4 to have your pattern. So you can use. So we get here. So and second, it's very expensive.
What?
This technology is expensive.
This is software and the machine is expensive.
No, I'm not talking about machine. Machine is just only, it's just one time, but I'm talking about the running cost for the tile. This is, it's like, for one sheet, it starts from $10. So when you have like this one, did $10. It was $10. So when you, and here, like I did this mask, and it was bad, you know? So I lose money here. But with the other technology, with the other techniques, I use it. So later we will talk about laser and how I merge between them, how I merge between the two techniques together. Laser. Laser, it's, everybody I believe like know what is laser. Okay, so they usually use it for promotional materials and sometimes industrial, and they have a very powerful machines now. What I work with is just only, we have the measurement with the watt, how many watts you use it for the laser. So what I have, it's very powerful. It's just only 30 watt. What they use it in industrial, it's up to 4K watt. I just only have a small one. And it depends on the power and how you can use it. So when I start using a laser, I have to understand what is the laser. The laser itself, I will show you. I contact the company and they have some videos, nice video about what is the laser. But this is not the same brand I work with.
A laser beam is basically radiation, similar to light that a light bulb emits. there are three big differences. The light bulb emits several wavelengths, but the laser has only one wavelength, meaning it is monochromatic. The light bulb radiates in all directions, whereas the beam of the laser is directed. The laser light is coherent, so the wave trains are much longer than those from a light.
So here, when he talk about, we know all this story when we were kids. Okay, so we have to move our hand when we have this lens, and we have to move our hand ups and down to have the focal point, right? To start burn, to start. So this is exactly the laser. But here, when he did this, he used here lens to make the light. It's very powerful, okay? So we have to have this, the light when it comes like this. And it goes for the lens, and it becomes straight, and then it comes again. So here, this is the focal point. I use it to burn. So in a machine, laser machine, I have to measure the height, the distance between the lens and the project. If it's wood, whatever, any kind, I have a tool to measure the distance here. So if this lens, we give a number like 2, it means it's 2 inch. So I have to have 2 inch space to have the focal point. I have a powerful light here. If it's here, no, it will become still weak. If it's here, it become very weak because it's already start going. So we have to have it measured exactly. So this is a point. And the laser, how it works? It works with pulses. Pulse. So how many pulses per second? Sometimes it starts up to 1,000 pulses per second. So, and it eats. I'll show you now.
But what does laser mean anyway? Laser is an acronym for Light Amplification by Stimulated Emission of Radiation. Sounds complicated at first, but actually it is not. A laser consists of a laser medium, for example, a gas, an energy source, pump, and 2 mirrors, one of which is partially transmissive. The laser medium consists of particles that are in their basic state. The pump feeds energy into the particles, and they rise to a higher energy level. If any of these particles then falls back into their basic state, energy is released in the form of a photon, also called light quantum. If this photon then hits another excited particle, then it's forced back into the basic state, releasing another photon. This is referred to as stimulated emission. If these photons hit other excited particles, then further photons are released, and so on. A sort of photon avalanche is triggered. Energy is repeatedly pumped into the laser medium, stimulating the particles, so that they can release more photons. The mirrors reflect the photons, thereby increasing the number of photons further and further. A directional beam is formed. This beam can leave the laser through the partially transmissive mirror and is directed onto the material, where it engraves, marks, or cuts the desired motif.
So with the laser, you can mark, engrave, and cut. So mark, you have the stone, it was somewhere. No, this is not a laser. Laser can't do this. You have this one, look here, you have it beside you. This is a laser. So you can see the difference now. So this is a laser, and this is sandblasting. So you can see the difference here. So we have our artwork, and in this case, we can do this. It's a paper, and we can cut paper by laser. And usually when I cut a laser like paper, I have like 2-3 layers. So I have this, and I can see the difference here. And if you look up, you can see it is still connected because the pulses is not powerful. It was powerful here, but not powerful here. So it's effect, but it's still. But I can take this out once I start use the manual. Yeah. But if you look, you can see it's still connected because the pulses. So you can, from here, you can see the difference. So this is a cut. Okay, it's on a paper cutting, and it's on a wood cutting. Wood. So this it comes from here. Yeah, you can see.
For the wood, this is more powerful laser.
Yeah. We have 3 factors here: speed, and power, and pulses. And it's like a resolution when you have a dots. So how many pulses it goes per second, how powerful you can use, and the speed. If it's very slow, it can go uncut. If it's very fast, just only mark, make a line. We have a speed, we have a power, and I will show you something here. This is the software I use to do my project. Okay? So when I open here setting, you can see here. Here it's color. I can use it in a design. So I can, one project, I don't need cut and then take the project and then engrave and then I mark. No, I can do all this in one project. Like this one. This one, it has everything. How? I have cut, I have mark, engrave, sorry, and I have a line around, it's just only mark. So I have 3, what do you call it? The 3 major activity of process of the laser. So you can see it here, you can see in this wood. It's cutting, and I cut all the outline. And I just, here, I engrave a little bit and just mark line to place my tiles. So here in my software, I can have the same project with different colors. So when I send the project, I put the project and I place it and I measure the height in the machine and I just keep it running. So it starts, and this is how it starts. Like, okay, black, it will raster. It means engrave. Here, red vector, it means just only, and it depends on the speed. I can control here the power and the speed. If the speed is very low, it means it's not marked. Vector here, it means it's just only line. It goes or for outline for the project. So if I give it very high speed, it's just only mark. If I give very low speed and very powerful, it will be cut. It goes go and cut. It depends on the material and thickness, and this is calculation, you have it. And this software, they have inside like database for, I don't know, they said like 10,000 setting or something. I don't know. Yeah, it's ready made, but by experience, I use this like, okay? So here how I can start doing my, and I show you now, how I do this. First, I have my artboard here. I set this. It's the same exactly like the workspace of the machine. So if I locate it anywhere, it means it will be in the same position in the machine. Okay. So I start. Okay, I have my project, I send it here. You see, if it's very light, it looks like very light, right? Because the laser, it goes for something it called hairline. If it's bold, it will not recognize like it's vector. I can work with it as a marker. I can use it as a raster to engrave, but not to cut. So in this case, if you look up here, I give it, it's very small, and this is equal the hairline. So when I send this design to the machine, it understands now I can cut or I can just only make an outline. So if I have any project like the one you saw it now, I will show you. All what I need, just put it like this, like this. So this project here, this is the one it was in your hand. One. Okay, I have black, and I have a red, and I have a blue. So blue for cutting, black for engraving, red for marking. So I have three functions in one project, and just only I send this to the laser machine, and it goes everything. All what I need, just put the project, sure the height from the length to the project, it's 2 inch, and then I start. When we talk about engraving on wood, we have this one. It's a natural. So the first one, it was cutting, and this is engrave.
Sometimes they take thick materials, don't go in.
And I did something else. I know it's complicated. I did this. So what I did here, I covered my, because I need to paint the wood. So I cover with a mask tape, and then I send it to the laser machine, and it's engraved. So when I engrave, I have to, after I engrave, I just keep the mask, and I just spray very light color, and I keep it until dry, and I have to take it one by one. You can't imagine how this project is so complicated. Yeah, no, I'm talking about how you have to take it one by one. It's very small. And this is the funny part. This is very funny. Wood, it's supposed to be solid, right? And laser, they have a design, and they make the wood very flexible. It becomes very flexible. So you can bend it like this. So you have project, so it comes from this. You see how they cut it?
I know.
So. So back to sandblasting, because I missed something. And when I was working with sandblasting and engrave, like what you see here, it's very deep. I can do something very quick and just only sanding and keep surface like this. Can you pass it? So this is fast.
Yeah, fast
Yeah.
process.
Yeah. So we have here the logo for the workshop. It's here, right? And it's here. Here from Al Hamra. Here is the same design and 3 different techniques to engrave. As you see here, it's the same design and 3 different ways to can engrave. And stone. It's a stone, natural stone, and
Did you try on the metals?
yeah, I did, but it's not goes very deep, but you can see the difference
What is the reason it's not going deep?
because metal is very powerful, but it goes, but it takes time. But the workshop here, it's wood, stone, and tiles. So I don't need to bring something else. I can do in many different materials, but here's we talk about something, so I just focus on what they talk about now. And here on wood, just only laser, and in wood, sandblasting. So you can see the difference here.
Why is it black?
I just painted to see the difference. And you can see laser, I just paint, and when it's engraved, just etching and goes for the basic color of the wood. So you can see the difference. So you can use it in your design. If you can have a stain wood or something, and you can do it, and then you can engrave, so you can.
Burning.
No, this is not a burning. This is take the first layer without burning. The other piece, it was burning. So you can see the difference here between. So how this natural effect, and you see here the leaves and the fabric.
This starting takes how long?
It takes around 5-6 minutes. It takes around 7 minutes. No, but this is a laser and this is sandblasting. And we have this design here. It's on a paper. And the same design, it becomes here.
That's small.
So it becomes here. It's piece of the same. You can see it here. Back to what we were talking about. We talk about intersection of technology and crafts. So before, when we try to cut a stone, what we can use to cut a stone, just only chisel, and we just use a hand to cut a stone, right? So when they create the robot to do some stuff and they merge it between the cutting stone, they create something. You will see it now. I'll show you a video for a new technique to cutting stone now. It's a diamond, and they have a 3D cutting now on a natural stone. Yeah, it's not really tough because it takes time to cut and need water to cool. And what I'm talking about here, I'm talking about how to use the technology, and all what you need was all this advanced technology it's nothing without your creativity. So if you understand the concept of design and you merge between all these techniques together, you can have something as what you see now. But without creativity, nothing. It's just only car without driver, you know? So another one was the cutting, because I'm interested with cutting and see how you can use water jet. It cut straight forward to stone, natural stone. And they made something 3D, so it can cut with angle. So you can have the same process. We saw it yesterday, they do it by hand. And when I asked the master, I can't remember, Said, when I asked him if you can use a laser, a water jet, he said no, because water jet, it cut straight. But I told him, no, they have a technology now, it can cut with the angle. So you can have this V shape and you can use it. So I have it here. It can cut not straight, it can also by angle. This is a straight cut, and then up to now, it is the process, it's the real time. And then they will fast it, they make it fast. We can use the technology, we can speed up the process of any kind of technique. So when we merge between a Moroccan style, Iranian style, and we can cut stones with different colors, and we can have the same process. You can't imagine how we can cut with time and accuracy. So I have another techniques, it's called sublimation. And sublimation, it's a chemical process. What is a sublimation first? Any material, it comes, they said, we have three forms of material. We have a solid, we have a liquid, and we have a gas. And if you have something that's solid, and it goes to, if you heat it, it comes to liquid, and then it comes to gas. So the sublimation, it's something, it jumps from solid to gas without going to liquid. So we have a nice video here.
Hello, I'm Bruce Yankee, and today I'm going to take a look at the sublimation of iodine. Now, our precautions for this experiment include safety glasses. I'm going to use small amounts of the iodine, and I'm doing it by an exhaust fan so I don't come in contact with gas when the iodine is heated. I want to start by taking a look at some iodine crystals. I'll put some on the paper here, and as you can see, they're very small. They have a metallic look to them, but they're definitely a non-metal. Now, as the iodine sits, it actually evaporates. And if we look at the paper, it's actually stained brown. That's because particles from the iodine are actually working their way into the paper and through it down to the paper underneath it. In the next step, what I'd like to do is heat some iodine and observe the results. So I'm just going to use a couple really small crystals. We're going to put them in this test tube, and then we're going to put it over a low flame. Now, if we heat this crystal up to about 237 degrees Fahrenheit, it'll change directly from a solid into a gas without changing into the liquid state. This process is called sublimation. Now, when the iodine gas starts to cool, it'll change directly back from a gas into a solid again. When it drops below 237 degrees, it'll start to recrystallize. So, if we take a look at this purple gas and I start pouring it out, you'll notice that it changes from purple to a gray. That's the iodine starting to recrystallize. I'm heating the test tube up a second time, and when I have it nice and hot, I'm going to take the iodine and pour it as a gas. It's very heavy, so it pours very nicely. But when it hits the surface of the paper, it cools enough that the iodine changes once again from a gas back into a solid, and it leaves a nice film of iodine crystals on the surface of the paper. Now we can see that change one last time. If I keep the flame moving, I can get the iodine hot enough so that it changes back from a solid to a gas again, but hopefully not hot enough so that the paper catches on fire.
So why I show this? They create a dye or ink, use this technology. It's called sublimation ink. And this sublimation ink, it goes under heat from solid to gas. So they create this ink with a water base, and they have a holder or paper holder just only to keep this image or the ink. So they use the technology of ink printing, inkjet printing, and they use this dye, and they have a paper, and this paper, it's pre-coated just only to hold the ink, and then when you put this ink on heat, it transfers to other surface, like when you see here, the gas, it become colorful. So they create a material with pre-coated with blue ester coated. And when they do this, we start doing designs, and we can print on wood, on aluminum, on marble, on anything. If we just we put a coat on this material. So I have here piece of wood. It's pre-coated, and we can see the difference here. You can't see there is any difference. It's just only a nice finish. But if you look with the light, you can see a transparent coat.
So the wood comes like wood.
It's wood. It's real. It's natural wood. Yeah, and just spray it, and it's like a mass production for it. So it's pre-coated. And I bought this from the company, and I have a special printer with ink, and I print like this design here. So when I print this design, I need to put it here, and under heat press for 400 Fahrenheit, it goes from here to the surface. And it becomes inside, not on, it's inside. So this piece of wood, I can do it. I use this design here. And this is after I put it in the heat press, so you see the difference. It looks like it's not clear, right? So this piece of paper, it becomes here on wood. So you can see it here. And if you try to scratch it, no way, because it's already inside, because it's attached under this treatment of heat and the natural of the ink itself. And we use it also for ceramic. Ceramic, it takes around 8 up to 9, like 8 minutes to cook, and we have on ceramic tile. You can wash it, you can do anything. It's indoor, it's not outdoor, it's sensitive to light, so ultraviolet can, UV light, so it can live for 2 years outside, inside forever. So this is another process. You can use the technology. And here, the logo. We did it, so it comes from here. Within 2 years, because it's very sensitive to ultraviolet. Like, it's feed out. Yeah, exactly. Because the natural is ink, but indoor, anything. It takes 2 years to fade out, but indoor it's forever, and it's anti-scratch, and you can use it for heat, for anything. Photograph, HD photograph, aluminum, wood, anything. Like here. Yeah, resolution, it's HD. You can go to HD. It depends on the technology of printer you use, and the paper and the ink. It's, and here, you see, it's called HP. It's hardboard and pre-coated, and you can print on it. Yeah, this is a special paper, and this is only for sublimation. And you can have a sublimation printer, sublimation ink, and sublimation paper. Yeah, sometimes they use Epson printer, and they just a new one, so it's clean, and they can use the sublimation ink. But nowadays they have sublimation printer, just only for sublimation ink. You can print on textile.
We wash them in the machine.
It's perfect.
Why you said 2 years?
I'm talking about I'm talking about the ceramic. If you use it outside, because the light of the sun, you have UV, so it's effect. Mm-hmm. But it will resist for more, because I search about the code for UV light, but still, like, you can't trust because it's still young. This technology, it's like 20 years or something now, but for last 5 years they use it a lot now.
Yes. Can I ask?
Okay.
Yeah.
Okay.
This has different colors.
Yeah.
But in the design sheet you have just one color.
No.
Or I don't see it. Yeah.
So you can have it.
So it's colorful.
You can print your picture.
So it's just one step to print this.
I have a
colors.
design. I will show you. I have a design here. I print the design on a inkjet printer for sublimation, on paper for sublimation, and then I put it together in a heat press, and I just press, and after it finishes, and I take it out, you see it like this.
So what's the heat press? Have you got video of that? Or what kind
Artwork, print it, adjust the heat, adjust the time, it's 8 minutes, adjust the power when you press it, and you put your artwork, you put your tile, it's pre-coated, it's not regular tile. Heat press. 8 minutes. You have it. So we can use it for wood. And I did my research about the coat, and it's a lot of process, but if I bring the coat, I can have this piece of wood, natural piece of wood, and just only spray it. And when I spray it, I have to leave it to dry for 4 hours, and then I cook it on a stove for a little bit, like for 20 minutes or something. So the coat, it's already cooked and it's already on the material, so I can do all the process now. So if you look here, you will see it's not like the back. You'll see the difference. And in the back is the natural, so you see the difference now. Okay. Can you see now? It's the same image, right? Hello? Hello? Nobody, right or wrong? Is the same image?
Almost, okay.
Okay, almost.
Because the left one has a margin.
Yeah, I know, but I'm talking about so what's the difference here? The difference here, it's just only, Merrick, when we talked yesterday, when he talked about his techniques and how he used, and this is the difference. Here it's just only image. I can't control anything. It's just only one image, as you see. But the difference here, when I look, you see all these dots, how it's, here there is no dots. Here there is a lot of dots here. You can see the line. So here I can control everything. And here I can use it for any type of technology. I use it now. I use it for cutting. I can use it for a laser. I can use it for printing. So the difference here, to understand this vector and image. And here I can change the color easily. In this one, I can't. This one, I need to use a Photoshop or something. Here, in Illustrator or something, I can change the color for any, in the pattern here, any area I can change the color separately. And the difference here, when I make it bigger, you start see how it become pixels. And this is affecting, if you use it, laser can't understand what this, it's image. Laser can't understand. But here, the other one, I can go more. And wherever I go, it's still clean. So I have to understand the difference, and how can I do it? So the point here is, like, if you want to know and use the technology, you have to understand the digital design and how to build your pattern and your design first to make it short for any kind of process. This is especially for you, because